1. All the ports are, but that's beyond the scope of this video, so for that we're going to move on. Here's router 3. Let's go ahead and do the same thing here. Okay, interface 000. Let's see what IP we assign this one. This one's 5.6. To 5.2 mask. No shutdown. Okay, let's go into interface fast Ethernet 00. It spit text at me so I couldn't see what I was doing. Fast Ethernet 00. And the IP for this one's going to be 192.168.10.254. To a 5.0 mask. Okay. Exit, show IP in brief, and you'll notice that I did not turn on fast Ethernet port. Okay, here we go. Both are online. You also notice that here 0000 came up as soon as we configured the IP. Okay, all the interfaces are configured. Now, there is no way for this router 1, to know about the .20 network on this side, nor about the .10 network on this side of this router, because he is not directly connected to him. And you'll see that now. You'll see its route table now, and you'll see that all he knows about right now is what he's directly connected to. Show IP route. See the nomenclature here for C? That code stands for connected. So you'll see that both of these links are the only ones he knows about. He doesn't know about anything else. Anything else he learns about, he will list here in his route table with a code signifying how he learned it. If it's either directly connected, a default route, whatever it is, RIP, any of the protocols you might be running. Okay, let's do the same thing here. You'll notice that he only knows about the connections, the subnets that he's directly connected to. In other words, router 3 has no idea about router 2's networks, the two that are directly connected to router 2. Same thing with router 2. Doesn't know about anything that router 1 is connected to, or router 3. So for this reason, we're going to configure a routing protocol. We're going to use an interior routing protocol. We're not going to get into border routing protocols like BGP. We're just going to talk about internal routing for now. And the protocol we're going to use is EIGRP, which stands for Enhanced Interior Gateway Routing Protocol. It's a Cisco proprietary routing protocol, which is distance vector based. And it uses 6 metrics, so it's a step above RIP, so I like it. We're going to use it. Let's go ahead and configure router 1 with it. Now from global mode, what we type in is I'm thinking about what autonomous number to give it, but I guess we can make it up. We'll make it 100. That's what we're going to use. The autonomous system number we're going to use is 100 for this group. Okay, there is a command called network. Now, network command basically turns EIGRP on these interfaces. It allows the interfaces to participate, but it also advertises those links. For the sake of argument, I'm going to put each one individually, and then I'm going to show you another example with router 2. 168. .5. On the left we have the .4 network. So there's the .4 network. Now how do we specify what it is? We actually use an inverse subnet mask. For zero bits means check, ones mean ignore. So basically it's the inverse of that mask. And I actually have a typo here. The inverse of that mask is 0.0.0.52 is 3. So there we go. We got one network in there, and now let's put the other one in there. .8. Okay, let's tell him about his neighbors. He's gonna have a neighbor 192.168.5.6 from his serial 00 port, which basically is letting him know that on the left, on his serial 00 port, he's going to have an EIGRP neighbor that can be reached at 5.6. Okay, let's put on the other neighbor 192.168.5.10 serial 0/1. Now let's just confirm that those are correct. Serial 0 goes to the left, serial 1 goes to the right. Perfect. Those neighbors are correct. No auto summary. We don't want it to auto summarize routes. Exit, exit. Notice if I do show IP route, he still doesn't know about anything just yet. Now in router 2, let's configure EIGRP. We said the atomic system was going to be 100. Now let's see what networks he's got. 192.168.5.8. 0.0.0.3 mask. Okay, for now I'm not going to add this network that's out here, and the reason I'm not going to add it is because I want you to see how it's not advertised, and the other routers will not know about it just yet until I advertise it to them. So let's do a neighbor 192.168.5.9 0.0, I'm sorry, serial 0/0, I believe is how it's connected. Let's check. Yep, 0/0/0. It can reach router 1 through 5.9. Perfect. No auto summary. I want you to notice something. It says neighbor 192.168.5.9, which is router 1, is up. No adjacency. So now we have a neighbor statement for both. Guess what? We both know about each other now, which is fantastic. Let's try to get router 3 to participate. Router 3, I'm going to do something a little different. Configure terminal, and then here we're going to type in router EIGRP autonomous system number 100. Now for network, I'm actually going to tell it something different. I'm going to type in network 192. Now if you realize something, both networks connected to this router start with 192.168. Now I'm not going to specify anything else. I'm going to leave it this way. Then I'm going to tell it, make sure that 192 matches, make sure that 168 matches, and I don't care about the rest. That's in essence what I'm doing by setting the first 2 octets to 0 and setting the second 2 sets of octets to 1, straight ones, which is 255. I'm telling it, check the interfaces that start with 192, start with 168. I don't care about the rest. As long as they match 192.168, I want those to participate in this EIGRP system. So let's go ahead and hit enter. And let's put in our neighbor statement, which is 5.5 off serial 00. Okay, we should see new, type in no auto summary as well. And that's how we got the new adjacency, and we also got a new adjacency up here. So all 3 are communicating now. The middle router has an adjacency with both router 2 and router 3, and routers 2 and 3 have an adjacency with the middle router. So let's see what we've learned so far. Let's look at router 1 and do a show IP route. Notice he learned about 5.8, which he's directly connected to. He knows about 5.4, which is directly connected. But look at what he learned through D. He learned through D, which is EIGRP, if you look up here. Through EIGRP, he learned about the 192.168.0 with a /24 mask. If you look at the network, that's actually the one belonging to router 3, this fast Ethernet port. Okay, and he knows that he can reach this network through his 000 because it's 000 is the subnet that he's directly connected to that router on. So to get to that network, he knows he needs to route it that way. What's interesting is that you see that he did not learn about 192.168.20 from router 2. And the reason for that is because in the network statement for EIGRP, he did not specify anything else except 192.168.5, and he said just this subnet by doing 0.0.0.3. By doing that, the only interface he's advertising, the only network he's advertising is this one. Let's take a look at this guy, router 3. Okay, here we go. We got through EIGRP we learned about 192.168.5.8. Now if you look at the diagram, 5.8 network is actually this one over here. Notice how he's connected to this network and this network, but he learned about this one through EIGRP. He still has not learned about this one either because this router 2, is not advertising that network just yet. So what we're going to do is let's put that network in router 2. Now we could do the same thing as we did before and leave it 192.168 everything, but we're going to go ahead and just put it in here anyways. I'm going to put it 0.0.0.255. So basically, any interface that starts with 192.168.20, I don't care about the last octet. So that's going to go ahead and bring that Ethernet port in here. Okay, let's exit here, exit here. Let's take a look. Not a change was made. Let's check router 3. Do show IP route. Okay. Notice how now he learned about the .20 network, which is the one he's not directly connected to. It's actually on the other side. So now the router connected directly to accounting is able to talk to the network segment that belongs to sales. Without EIGRP or some routing protocol letting him know, he wouldn't have known. He would have only known about his directly connected routes. But thanks to EIGRP, now this router can communicate with the .20 network, which is clear on the other side of the diagram. Let's make sure this guy also knows about it. And intuitively, you know that he does know, because the only way for router 3 to realize router 2's routes is through router 1, since that's who he's connected to. So if this guy doesn't know it, he wouldn't either. And yep, there it is. Okay, let's make sure this guy knows about everything. So as you can see now, this network is fully routable now. You can get from any side of the network to any other side of the network through these routers, only because they know about the routes to each other. And that concludes this presentation. Any questions or comments, please post them, and I'll be happy to answer. Thank you.